Okay, everybody, this is chapter 3, section 5. This is going to talk a little bit about triangles, and we're going to do some proofs here. So remember, in proofs, we're going to talk about things that you can see in the, hopefully we got a picture. If we don't have a picture, then draw one. But from the picture, being able to tell us what you know through the rules that hopefully you guys keep remembering because you keep studying. Okay, if you don't study this stuff and look over it more than occasionally, you're gonna kind of forget. Okay, so let's go through this first theorem on the top. This is a really important one. It says the sum of the interior angles of a triangle is 180 degrees. Okay, this is a huge theorem that we use all year long. Let's draw a picture to illustrate this. Any kind of triangle. I won't draw one with 90 degrees, but just know, 90-degree triangle is going to have an angle that's right, which means it's 90. Okay. I'm going to just label each one with a letter. Okay, to illustrate this. Now, taking the rule, it says the sum of. So remember, the sum of is to add. So I'm going to add the interior angles. Interior angles of a triangle, the angles that are made up inside where all the sides are kind of coming together at each vertex. Okay, so the sum of those angles, so those angles are A and B and C, and I can add them together. They always equal 180 degrees. If they don't, then it's really not a triangle. Okay, so once in a while, especially down the road, we'll try to use that a little bit to make sure you understand the rule. But this is just a huge concept that we continually use basically all year long. So you got to make sure you have that one down. Okay, we're going to do a proof of that particular one. So if you guys could go ahead and draw this picture that's in the box, label it all up with everything you got. So once again, guys, during video notes, I typically try to go through quickly on these. So hit pause, do your notes wherever get caught up, and then come back, hitting play, and we'll continue on. All right, once you've got that picture drawn, you're going to go ahead and draw a two-column proof. And we're given that you have a triangle A, B, and C. So one, you got to know that all those angles are going to equal 180 degrees. In this case, it's going to be angle A plus angle 2 plus angle C is equal to 180. Okay. One other thing, just it's kind of, you don't know it, but we need to assume here. This is a point. This is a theorem we got a couple sections ago. That point B, through any point, you can draw a line that's parallel to another line. And so it's not given to you. I think it probably should be, but I think the authors are trying to assume that you can see it or know it, and that's not really good. But I'm going to assume that those two lines are parallel. Okay. Don't say that. There's nothing here that can really prove it. So we're just going to kind of go ahead and say that right off the bat. Okay. So in my first step, triangle ABC is given. And what I need to prove is that angle 1 plus angle A plus angle 2 plus angle C equals 180. Now, I know there's a theorem that says that, but I got to prove it. Okay. So now we got to start here, and we got to think of something that can really say that this is that. All right. So what do you see and what do you know? Well, first off, I think I can say that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees because that's a line. So it's definition. Well, hold on a second. You'll learn how to write. Definition of a line. Okay. I know that I can, if I got a straight line It's cut up into a bunch of angles that I can add them all together. It equals 180 degrees, okay? All right, so there's a start. You know, what else can I say or do or see here, okay? So I know that I got a line here and a line here that are parallel. And we kind of had a problem a while ago, a couple sections ago. Can I extend lines on a figure? I think we had like a parallelogram or something. Can we extend lines on a figure? Yeah, you can. So, you know, basically right here, I can extend those lines. I could do the same thing over here. I can extend that one, okay? And now all of a sudden, I think I can start using this transversal stuff, because now I've got two lines that are parallel. The PR and the AC are parallel to each other, and now the lines AB and BC create transversals, okay? So if you go back and remember those different angle groups, can I say that angle 3, let me get the black here so I don't get too colorful, is congruent to angle C? Can I say that? And C and A, you know, are really inside. Okay. Can I say that? Is angle 3 congruent to angle C? And it is, okay? So go ahead and do that. If I go back and look at the other transversal then, and that's, I'm sorry, time out. What kind of angles are 3 and C in a transversal? They're alternate interior angles, okay? All right, so do you think I can do that with the other triangle, or for the other transversal line, this guy? Well, I think I can say that angle A is congruent to angle 1, because they're on, you know, on a transversal between two lines that are parallel. So if they're on alternate sides of the transversal and between the lines, they're also alternate interior angles. Okay. Okay. Are we good there? So hopefully you saw that. Maybe it didn't, but you got to make sure that you can use the images to your advantage. We're playing rules by the game. Now I'm going to go back to what I have to prove here for a second. Okay, and be able to say, you know, if I've got those angles, and you know, I'm trying to prove this, and I wrote this out. Okay, at the very beginning, that was this line up here was made by those 3 angles, and I kind of stated that because, hey, I saw it, I know I can say it, I'm going to put it down. Well, can I now take, in that particular picture, angle 3 is equal to angle C, and I'm going to kind of draw here on this for a second. Can I substitute C in for 3 up there? And can I substitute A for 1 right here? Okay. So remember too, in our proofs, you want to use the picture, but sometimes also you're going to use the different steps that you have in the steps that you've done in your proof. So let's just do that. Math says I can substitute, and I'm going to do that. So I'm going to say angle A which was 1 is now A. Angle 2 I did nothing with. Angle 3 I'm now calling it angle C because they're equal, is 180 degrees. What did I have to prove? I screwed that up. I put 3 instead of C. My fault. Okay. What did I have to prove, you guys? I have to prove that, and I did this by substitution. Okay. Now that's a pretty, in my opinion, kind of a difficult proof. Maybe not for you guys in another week or 2 or whatever on a review, because now you've seen some different things. you kind of get hopefully the idea, how do I get through a proof? But you need to stand back and for a second just ask yourself, is there anything in there that I didn't know or should have known or I could see in the picture? And, you know, can I manipulate things to help me get what I want? I mean, I took these 2 steps here in the middle kind of and used that to manipulate. But I knew that I have to do stuff like that to get a proof, okay? So hopefully you kind of follow that one, all right? But once again, we'll do some practice on this. To get good at proofs, you just have to do a bunch of them and try, okay? All right. So we're going to go ahead and why don't we draw example A and B in your notes, okay? And we're going to use I think we're going to use the triangle sum principle because we've got, you know, 3 angles in a triangle, but we're trying to find some, okay? So let's just remember that all the interior angles of any triangle are 180 degrees, no matter how they're drawn, okay? And to get that, you take the sum of them all. So I take all 3 of these angles, whether I have a value for them or not, and I'm going to set them equal to 180, because that's what that first theorem just told me I could do. Right? So I'm going to go ahead and put some like terms together. So 42 and 55 is 97 equals 180. And I can go ahead and subtract 97 from both sides, and I get 83. So this missing angle right here is 83 degrees. Okay. So now I come here on this one. This one's a little tricky, and there's actually 2 ways I could do this, but let's stick with the theorem. Take all 3 angles equals 90 or equals 180. So I know this is 90, right? So I can take all 3, add them together, equals 180. Okay, a simple theorem, but being used all the time, you got to have it down. Okay, so go ahead, put like terms together. 3x and 1x. I'm sorry, 2x and 1x is 3x. Plus 90 is 180. I can go ahead and start solving it. X equals 90 because I subtract 3x equals 90 because I subtracted 90 from both sides. And then I go ahead and divide by 3. Okay. And there's value for x. Now you got to be careful here because a lot of kids, you know, they solve for x and think, hey, I'm done. But especially in geometry and higher math classes, we're going to ask you to do something now with that answer. First off, this angle is going to be 30 because it's x. But this angle is 2 times x, so 2 times 30 is 60 degrees. Okay? All right. Yeah, hopefully at some point down the road, when you get better at this, you experience different questions, situations, whatever. And let's think about this. Every triangle, all the interior angles equal 180. Okay? Now, if you get a right triangle, you know that one of the angles is 90, and the other 2 have to add up to 90 so that all 3 equal 180. Okay? So I could have set up this problem like this instead. And, you know, it's not a huge deal. But you know, the numbers are smaller, perhaps. It makes it a little bit easier. Chance of mistake is decreased a little bit. Whatever. But I still, at some point, you know, that might be a good way for me to think, or to be able to approach a problem and kind of do it that way. So I would have got the same answer no matter what. So I got to make sure that we got that. Okay. All right. If we get down to this theorem here, if you could, don't worry about the number. If you could write down this, though, this is a pretty good one, too. This one seems to kind of mess kids up a little bit, but hopefully I can explain it to you in a way that you'll understand it. Okay, sorry about that. The sum of an exterior angle, so it's an angle outside the triangle. Cross symbol triangle. The sum of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. So non-adjacent in this case means not next to. let's go over this really quick so we get this. This angle 2x plus 10 is exterior. It's not inside the triangle, okay? And it's going to be equal to the two non-adjacent. This angle right here, I'll put a question mark. That angle right there is adjacent. It's next to the angle that we're kind of talking about, okay? So this angle and this angle are non-adjacent, okay? So let's go back to the theorem. It says the sum of an interior angle of a triangle, and there's said sum because I think they're adding this to it. It should really say sum. It should just say the measure, okay? But in this case, we have an algebraic expression. Let me go back. The sum of an exterior angle of a triangle is equal to the sum of the measures of the non-adjacent interior angles, okay? So I'm taking the one that's outside is equal to the sum of the two inside that are not next to it, okay? So, you know, big thing there. Need to make sure that we kind of can read the words, and the words sometimes get kind of crazy here, okay? But now I want to go ahead and solve it for x, okay? So I'm going to go ahead and I'm going to subtract x from both sides. Okay, I'm going to go ahead now solve it for x by subtracting 10. And I get x is 55. Okay. So that means this angle is 55. Right? But I need to probably find this angle too, right? So 2 times 55, plug that in. I get 110. And then 110 plus 10 is going to give me that this angle is 120 degrees. Okay. Well, let's prove it. Okay, there's a bunch of things I want to talk about this question because it lends a lot of explanation. So the two angles now, I got this was 55, that was 65. It's supposed to be equal to, you know, up here. So I'm going to take 55 and plug it in for x there, and I'm going to plug it in for x here. Okay. So 2 times 55, I said before, was 110 plus 10. 65 and 55 is 120. 110 and 10 is 120. Okay. So we proved that what we got was correct. Okay. All right. I'm going to erase some of this garbage here and try to explain something to you. Hopefully this makes some sense. You know, where did this theorem come from? Okay. And you got to remember, a lot of our math really comes from scholars in Egypt when they're building the pyramids, and some scholars in, you know, you learn probably like Mesopotamia, which is like Iran and Iraq now. There was a lot of scholars back then that were Muslim that really kind of advanced algebra, and then the Greeks kind of showed up and they really kind of expanded that into, you know, what we would have is like higher algebra and into calculus, stuff like that. So these guys were coming up with this stuff. This stuff's been around for a long time. Okay. Anyway, my point is that first off, you know that a triangle, we just learned that a triangle, all the interior angles equal 180 degrees. Okay. And if you look at this piece here, you know, the bottom of the triangle, and I extend it. All right, I took that triangle, the base of the triangle, and I extended it into a line. Well, we also learned that a line is 180 degrees. We've known that for a little while now. So this angle right here, where I put the question mark, that angle right there, when I add it to this one, should give me 180. But this angle right here, when I add it to these other two, should give me 180. So this angle right here is going to help me in two different situations. It's going to help me get that this triangle is 180 degrees, but it's also going to help me find that the line's 180. Okay. Now, if we go back here, these are the two interior angles that I have. I add them together, I get 120. Okay. Well, 180 minus 120 gives me 60 degrees. So they didn't ask for it, but that angle should be 60 degrees. Okay. I took 55 because that's what I got for X back here when we started way back when. When I plugged it in here, which is right here, I got 120. Well, line's 180, right? Once again, 180 minus 120 is 60 degrees. So this angle right here really represents two different situations. That you got a line, you got a triangle that are both going to be 180, are kind of linked together by that one angle. Okay, so that's where this kind of theorem comes from. This exterior angle is equal to the sum of these two, because this angle right here is common to both. Okay, all right. Going here, if you could draw this for me, please, and label it up with all the different stuff that they give you. Once you get that done, if you could draw a two-column proof. And we're going to go ahead and take what they give you. Now, they're giving me these two things, okay? They don't really say that. Let's put that into our first step. Okay, first step is always given. Sometimes the book messes with us and they start off with something else besides the given, but for us, we're always going to start what they give us goes in the first step. Okay, and draw on it. Okay, line L is parallel to line M. So I'm going to draw that. Line AB is perpendicular to line BC. So AB is this one right here is perpendicular to BC. So I'm going to show that that's right. Okay. Okay. Now I need you guys to kind of go with me here. We need to remember when I see or hear I have parallel lines, I want to think right off the bat transversal. Okay. We got all these lines going on. If I see parallel, I'm thinking transversal. And remember too, we can extend stuff. So I'm going to extend this line here and here. Do I have a transversal? Yeah, I do. Can I extend this line here and here and get a second transversal? Yes, I do. Okay. So we're going to go ahead and kind of work this one out a little bit and see what we can get. Okay. So what do you know? What do you see? What do you know? Okay. And I forgot. Hold on a second here. We want to get the measure of angles 1, 2, and 3. So maybe we don't have to do a proof. Well, let's do this anyways, okay? No, let's not. Got ahead of myself here. No, that's good. Okay, let's just find what are the measures of angles 1, angles 2, and angles 3. Okay, but I got all this stuff that was given to me. Okay, let's start with 1. What should angle 1 be? What's the measure of that? Well, once again, if you're thinking transversals, okay, what angles would this be in a transversal? If you guys said same side interior angles, then I should be able to say that angle 120 plus angle 1 is going to equal 180, and that's by same side interior angles. Well, if I subtract 120 from both sides, I get angle 1 is equal to 60 degrees. So angle 1 is 60 degrees, okay? Angle 2, well, they told me the two lines were perpendicular to each other, and I know perpendicular means that they're at a right angle, and right angles are always 90. So, you know, that's pretty easy. So angle 2 equals 90 degrees, and that's why, in this case, definition perpendicular lines. Okay. So that's 90. All right. Now, if I look at this, you know, that's 120, and I'm finding the interior angles. If that's a 120, then I should, and I'll call this X. Let's just do that. 120 plus X equals 180 because they create a line together. And if I solve that, I get X is 60. And that's why the definition of a line. So I could use 180 degrees to help me with that. So this is going to be 60. How do I find angle 3? Now I got to be careful here because I can't really use this transversal line here because these two angles are part of the interior angles. But I know that a triangle is equal to 180. Okay, I got two of them. How do I get the third? Okay, well I can go 90 plus 60 plus angle 3 equals 180. Okay. 90 and 60 is 150. I'm going to subtract it from both sides, so that gives me 30 degrees for angle 3, and that's going to be the definition of a triangle. Okay, so angle 3 equals 30. Okay, so that's a test question. I started off with a proof. Forgot that we had to just find angles on this one, but I left it as a proof, kind of showing you how I can, what my thought process is, and be able to get all those. Okay. All right. So 3.6 is a construction thing. We'll do that at different times. So that kind of finishes 3.5 for us. If you got any questions, please make sure that you get a hold of me and we can kind of go over things and get that fixed. Okay. Thanks.